Hello, everyone. Welcome back to another severe weather analysis. Tonight, we will be analyzing the severe threat for severe thunderstorms across Alberta and Saskatchewan for Saturday, July 11th. Um, right now, a good place to start, I guess, to kind of discuss what's currently happening across the prairies and change our view here. Um, Take a look at the nighttime microphysics. This channel can kind of show you where your moisture plumes are and your low clouds are when the sun goes down, which can be very useful. But we can see strong, severe thunderstorms that are across eastern Saskatchewan right now. Earlier in the day, you had a very strong supercell near the North Battleford area, and it had very impressive presentation on radar, and I believe produced probably a very strong rain wrapped tornado, um, and may have done some damage. I think I heard some reports of damage, and later on in the afternoon, at around 3 o'clock, you had storms fire, kind of southwest of Saskatoon. I was on these supercells, and there's definitely a lot of spin in the atmosphere. Um, I saw a couple of ropes come out of the storms. Didn't really see a full condensed tornado. A lot of circulations, but overall, lots of energy in the atmosphere tonight. And you have a low-level jet that's currently supporting these thunderstorms in eastern Saskatchewan. Areas like Yorkton and northward up to Kenora, and northward there, all the way east to Duck Mountain in Manitoba. And these storms could have tornado potential persist for the next couple of hours, although you have your instability is waning, but you have a very deep moist layer, so that low level jet can still support somewhat surface-based convection if your mesocyclones are strong enough to drill through that stable layer. Um, Looking back to the Pacific to kind of see where our upper level energy is, which will be the most important thing for tomorrow, and we can kind of guesstimate based off of the satellite where things may end up for tomorrow. You can see a kind of a just very broad cyclonic flow still across the western Pacific there. Um, very big ridging that kind of extends out here. You can kind of see this very wavy pattern here extending onto the Pacific Northwest and British Columbia coast there. And at the gradient of this flow, between this trough that's sitting here, this pool of cold air in the upper atmosphere, and this ridge across the four corners of the United States. You have this very strong jet stream that's flowing through here, and that provides the necessary wind shear for supercell thunderstorm development and very strong organized multicellular clusters that have brought a lot of damage to the prairies. Very strong MCS that went through Saskatoon, I believe, a couple nights ago, and had some action near Swift Current last week with a very powerful, almost a derecho. But to continue on talking about the water vapor here, again, just this very strong flow. This upper level low, you can see it's kind of like you have a couple perturbations that extend northward. It's kind of sheared out a bit, and you might have some stronger flow on the backside here, which can strengthen the system and make it more of a high amplitude shape and kind of give it more of like this sort of shape instead of circular. And if coming in the next couple of days, it doesn't look like it's going to happen tomorrow. But this feature down here, this dark feature in the water vapor imagery here. It's kind of moving through the base of the larger scale circulation. Is definitely interesting. Um, that will, if this ejects into kind of a negatively tilted shape, um, something like this, into the prairies, come peak heating time, then that would be your ideal weather maker for very significant severe weather. Um, we will discuss coming up the issues that you may have with getting storms tomorrow, even though you are likely to have a very volatile environment. So, but it looks like this guy just kind of going off the flow and guesstimating here. Um, you likely have a lot of advection of vorticity to kind of keep pushing this guy northwestward. It's embedded in this larger flow here, so I don't really see any reason why it would um, kind of meander away from the jet stream. It should just kind of keep propagating up until into western Alberta here, where um, it may interact with some baroclinic zones, and it could deepen a bit. You could get a cyclone that forms off of that, and then and as well as any least cyclogenesis effects. But as of right now, this is something to watch for sure. And the regional and global models at this point in the nighttime hours will have a good, I guess, final position of where this guy's going to end up and how much of an effect it will have, whether positive or negative, on tomorrow's severe threat. Because if it ejects into the morning and it occurs under some sort of warm air advection regime, you could have morning thunderstorms that negatively impact your air mass. But again, it's best to go to the weather models to kind of get a broader view of what's going to happen. But in short, our current observations tell us that the upper level flow is definitely still there, and it will persist for tomorrow to generate some very powerful supercells, likely across the prairies. One thing that's important to cover in terms of severe weather potential for a setup like tomorrow, which we will get into, that will have some issues with mid-level forcing. Your convection will likely be driven by thermodynamics and your weather fronts that's set up, and an important, I guess, proxy for figuring out if you're going to have the necessary surface heating available is where's the smoke? Is it going to blanket the skies? Are you going to have continued advection of smoke into the region? And we could take a look at the current fires that may be causing a problem as of now. Looking at the shortwave infrared imagery here, you can see this is for Friday afternoon here. You can see those fires really kind of cooking up in northern Saskatchewan there. Don't really see that Kamloops area fire down in southern BC that active on the imagery here. So that is a good thing in terms of your smoke for the region, and we can take a look at what is the smoke kind of accumulations looking like today. And you can actually see maybe a little small fire in northern Idaho, just along the British Columbia border there, that has continued. You're going to have continued southwesterly winds, and I'm assuming that the moisture is pretty low out there. 40-degree dew points. This is fair moisture for this terrain. But yeah, so you have maybe smoke advecting into the target area here. You can see as kind of the sun starts to go down here, you can kind of see maybe a bit of a haze, and it was this haze slash smoke wasn't obviously wasn't enough to suppress thunderstorms today, but but we will take a look at what the weather models are showing in terms of where they expect smoke to be. I'm not 1,000,000% sure how they, because I'm pretty sure that the HRRR can somehow forecast a fire's future intensity, and I'm not really sure how it does that. If it's statistics or it's somehow computing that. But for the sake of discussion, using the weather models will give us a good enough kind of estimation on how much smoke will be over the target area for tomorrow. This is the rapid refresh model for 3 o'clock Central Daylight Time tomorrow, and it is a very similar picture to today in terms of your smoke accumulation, near surface smoke, pretty low values here. You can see this is micrograms per meters cubed, pretty small. You're only likely to see the smoke in the evening hours and in the morning. In Saskatoon earlier this morning, I could see a bit of a haze, but as your sun came out, you kind of mixed out that air, and you had it was kind of diffracting on less of an angle, so you saw it less, and it didn't affect severe thunderstorm development today. Those temps had skyrocketed, I believe, all the way above 80 degrees, maybe 80 Fahrenheit, so about 27 degrees Celsius. Dew points in the low 20s. Very, very nice thermodynamic environment that we had today. Tomorrow's looking like that moisture is really going to build underneath the region that comes in the southeastern Saskatchewan. So your moisture is looking to be even crazier tomorrow, which is it's very impressive for the prairies. We usually do have a couple days a year where we have those 70 plus degree dew points, but haven't really seen it this year. But tomorrow is looking like that day where you could see possibly 80-degree dew points, particularly in southeastern Saskatchewan. But to go back on the topic of smoke, it doesn't look like it's gonna be too bad. We can look at vertically integrated smoke here. I believe, I don't know if the wrap, if they produce it for this model. We can take a look at the HRRR. HRRR smoke. 18Z should be, or 0Z would be better. Saturday we'll go 3 p.m. to kind of compare the two. They should be roughly the same, but the HRRR is going to cut off kind of the north of Saskatoon latitude. Vertically integrated smoke, you can see it's relatively low, maybe higher accumulations. You see that fire in northern Idaho there that will be pumping. The HRRR has it relatively weak still, and your Kamloops area fire down there. So you will likely have a similar situation today where you'll have some smoke accumulation on your boundaries, but I'm not quite sure if it will be visible and or will affect your surface heating too much. So in terms of smoke cover, I don't think it will be too bad, and your sun should be cooking out there quite a bit, and you're gonna get a very thermodynamically favorable environment for severe thunderstorms. So we'll move to the models next and kind of break down the synoptics and where you can expect thunderstorm development to be most probable for tomorrow, because that's the biggest question as of right now. So we'll move on to that. Taking a look at our synoptic scale picture here for tomorrow to kind of build a top-down view of what the larger scale motions will be in the atmosphere and where your areas of ascent and subsidence will be, and that can kind of give you an idea of how easy it will be for the atmosphere to generate severe thunderstorms and break that cap in the lower atmosphere. We can scroll through in the early morning hours here. You can see you get continued least cyclogenesis here. You have some sort of frontal zone into central Alberta here. That will build in the early morning hours, as you have that shortwave that we discussed over the Pacific. It really gets advected northeastwards, up and over here, and you'd like to have a nice bare clinic leaf shape in the water vapor imagery as that ejects over northwestern Alberta. Lots of frontogenesis and lifting associated with that along your front there. I'm sure some sort of low-level jet will be helping isotropic ascent up and over that warm frontal feature out there near the Edmonton area, and you could even have instability out there. We'll have to take a look at your where your warm sector is. As of now, looks like you're very strong forcing with that short wave currently in the Pacific. Will generally definitely generate lots of precipitation and or elevated thunderstorms at the very least in central Alberta here. And you can see throughout the day and early morning hours again, kind of continued cyclogenesis in southern Alberta, kind of north of Lethbridge there. And it kind of just sits here as it develops here. A strong flow moving over. You get diabatic or adiabatic heating, plus potential vorticity effects, conservation of potential vorticity. Essentially, just the same thing as a figure skater pulling in their arms. When the air parcels stretch up and over the mountains, that air kind of you decrease the diameter of it, and as a consequence of stretching that air, it has to rotate. It's actually a very similar effect as a tornado, but just on the larger scale of the atmosphere. Other effects, as you have a lot of that high momentum air hitting the Rocky Mountains, it will kind of, so we draw a diagram here. You're going to have your Rocky Mountains here. Very nice drawing here. And let's kind of draw our wind here. Your wind will kind of impinge on the mountains here and be forced up. Some of the air will be forced down, and you'll kind of have it will hit your tropopause in the higher stability air up in the upper atmosphere, and this air, once it hits, it will kind of deflect and kind of move eastward as well. So not only do you have your air parcels kind of stretching out here, you can imagine these cylinders, but you also have divergence right as this high momentum air hits the tropopause, kind of spreads out, and you overall the mountains are all mountain ranges, but Alberta especially, with these southwesterly jets, are very favorable for cyclogenesis, as we are well aware in the wintertime with the famous Alberta Clipper, that you can see sometimes multiple Alberta Clippers a week just because how efficient the Rockies are at producing these types of weather systems. But to continue our discussion here, very broad strong are southwesterly flow in mid levels. You can see this low pressure kind of elongates along this surface front here come evening hours, and that was looking for at today. Sorry for that, or for Friday. And it's Saturday. I mean, the picture is pretty much identical because, again, nothing has changed that much with the exception of the shortwave and the heat building. But might have a couple chunks of energy moving through the flow. We can look at 700 vorticity. You kind of see maybe some energy associated with maybe a mid-level front and or thunderstorm activity that developed uh, over this region tonight that might be moving through, and that could definitely be a focus for thunderstorms, um, other than your weather fronts. But to get a picture at 21Z here is to be 3 o'clock, so ideally peak daytime heating. Kind of drawn where the European is showing your surface features, maybe a low pressure kind of out here that extends down north of Calgary there. Front that would be somewhere in here. Warm front likely extending. You may have a multi-warm front structure, but on the synoptic scale, it kind of looks something like this, at least from the European. Might have a couple extra features, moving through as well. Putting back, you kind of see maybe down here some of that energy that moved, associated with some of the short waves. It's kind of affecting your temperature field. Here you can kind of see maybe some area of enhanced lift with your relative humidity field here. And European generates storms off of that, which is something to note for sure. But here you have your fronts here, which very baroclinic in Alberta here, and you'll have definitely enhanced wind shear along your warm front, with those southeasterly winds, kind of cranking in there. Fix this map. Your southeasterly is ripping here. Y'all moisture pooling kind of along this front, and most likely have a very volatile kinematic environment in the low levels. I would expect with this degree of baroclinicity, a very nice low level jet to pick up across your warm sector here, mainly due to the temperature difference. Especially, you'll probably have a nocturnal low level jet, because this air mass will stay. It probably won't go below like 20-ish degrees overnight at the very least. So you'll likely have a nocturnal low level jet, and we can kind of don't really have too strong of height falls. Your height falls mainly be confined to the front and in Alberta here. Height rises across the southern prairies. Again, to get storms down here, you would likely need short waves to move through, which the Euro actually does show a short wave moving near the Saskatchewan area by 3 o'clock. Again, we'll have to look at other model output to kind of compare and contrast that. But I do generally trust the Euro on these kind of medium resolution features, even if the short wave is convectively generated from storms today in the higher terrain. But in short, ridging across southeastern Saskatchewan, strong flow aloft. You could even have perturbations, like enhanced flow within that, which could help generate storms, or at least prime the environment and remove some of that capping. But on the large scale, you don't really favor too much continuous ascent throughout the day, besides thermal advection. Thermal advection, which would lead to your lifting, but at the same time, you'd be advecting very warm mid-level temperatures into the southern prairies. So that could definitely build a very strong cap to suppress thunderstorm development. Can move over to weather frontier and kind of break down the severe environment. A little more. this picture will tell you roughly the same thing. Um, Again, you kind of see the Euro is throwing out maybe a little bit of a 500 millibar shortwave, um, uh, kind of near the Lloydminster area, Meadow Lake, Prince Albert, and a very strong flow in the foothills as well. I'm sure if you get moisture down there, you're probably almost guaranteed a storm. And actually, this look here, um, this is a very nice look for supercell development, um, for kind of a classic look for Alberta here. I have no kind of doubt that you're gonna get uh, at least a couple supercells to fire in the foothills, just with this kind of classic of moisture pooling along your cold front and northeast winds. Again, this kind of classic uh, Alberta setup here. It could be a little messy again with that very strong forcing coming in. So an isolated supercell storm mode, I'm not really certain on. We can um, plot our front here. Take a look at your upper level flow. Alright, bulk shear would be better here. You can see a high degree of parallel flow to your boundary here. So combined with strong forcing and that cold front probably moving southeast, it could be a little messy along that front, unless it has some capping, which could help with that storm mode. That to get a more discrete storm mode, you can see maybe a little bit of warm air advection near that front with these warm temperatures moving in. So looking at most unstable Cape here, you can see that energy building out there for tomorrow. And yeah, overall, quite the nice supercell environment, but could be a little messy. And you can see very high instability building into kind of north of the Saskatchewan area along your warm front there. For tomorrow, you can take a look at the dew points that the Euro is throwing out. See here, a very humid air mass. A lot of that moisture has just been building. A lot of the rain in southwest Manitoba and all the rainfall that you've had out in these regions here, it's just kind of building underneath that upper level ridge and that cap from those very warm temperatures that have moved in. Thunderstorms today aren't really throwing out cold pools, so your moisture that is being modeled, I have high confidence that it will remain, and you're definitely going to see moisture values very similar to what the models are showing for tomorrow. Maybe looking at some of your other features that the Euro is showing. And your front, low pressure intersection there, warm front, something like that. Maybe have this kind of drier air moving in here as it kind of sinks and deposits moisture down here. It could get some sort of like pseudo dry line, dry punch moving in, differential mixing gradient. We can take a look at temperatures in this air here. Sample this here, 88 degrees, very warm. Overall, pretty warm. Southwest of the warm front. Again, you have those heat warnings for most of southern Saskatchewan. With humidex is expected to be above 40 degrees. So, yeah. But this could also be another focus for convection here. Move later into 0Z, 6 p.m. Central Daylight Time, and the Euro uh, does show convection out here. Again, I would take that with a grain of salt, but it is showing kind of your very hot air mass combined with the lift from that 700 millibar feature. Um, Maybe down here a bit, kind of see some energy moving through here. 850. You kind of see this energy that just moves into this region here. It's a very hot convective air mass. Will likely get things going. You'll probably have cumulus fields developing over the Cypress Hills and the higher terrain. The terrain does get a little bumpy out here, so as a first area for storm development away from your fronts could definitely be down here, and that could very well affect how things evolve kind of further north along your boundaries there. Um, Again, take a look at the NAM, kind of see the environment it's storing out. Moving in through the morning here, again it kind of shows this enhanced shortwave flow out here, and take a look at the frontal features. A little different shape in the cold front here. The Euro is kind of more like this shape, and the NAM is more kind of elongated here. You have your dry air moving in here, your dry punch. Shows some sort of secondary low pressure here, some sort of secondary front as well. Moving here. And I wouldn't really overanalyze this picture too much. This secondary surface low could be from convection. You can take a look at your vorticity fields. This is a bit interesting here. You have some sort of feature from the NAM here. Some sort of temperature gradient. I don't know if I would call it a cold front necessarily. Your cold front will likely be out here, but it is something that has some low level convergence associated with it. Might even just be some sort of vorticity that just has been elongated, but it is associated with this kind of temperature gradient at 850 and some sort of low level jet as well. So kind of interesting for the NAM. I wouldn't be surprised if it also throws out some precipitation for your southern target early. Maybe down near the Saskatchewan area as that energy kind of hits your warm front and your moisture and the pooling. But we'll take a look at again the strength of that cap. Unfortunately, only have a mixed layer or surface based SIN for the on weather front for the NAM here. But we could see along this kind of secondary front you remain capped. You remain capped from much of southeastern Saskatchewan. But the NAM does show like this interesting corridor here. We can maybe take a sounding. It's kind of in this area here. And well, this is your very convective and hot air mass. You know, LCLs. You're probably not going to get a thunderstorm out of this. Mixed layer cape, a 1600 mixed layer cape, but your parcels are going to be 2.5 kilometers up in the sky. So it's definitely interesting that this mixing can definitely help along any gradient that develops. Particularly kind of similar situation to today where you have this kind of mixing gradient boundary, and then your warm front that's kind of positioned up here, and it's looking like your highest probably tornado parameters would be up in this north of Saskatoon area, going back, stretching back into the Edmonton area there. Um, we can take a look at, let's get rid of this, take a look at your low level jet. Maybe even the GEFS would kind of remove some of these convective enhancements, and we can generate maybe a better kind of smoothed out picture of how things will look. But you have your main cold front here, kind of broad, strong flow here, and it's kind of an early low level jet, um, and a very strong upper level flow as well, with a possible shortwave feature moving through, which could definitely help on your northern threat there. But looking at, go back to the NAM, should probably take a look at some soundings. Put on the EHI. It's kind of maybe get a pre-convective, pre-storm soundings here. Maybe 2 o'clock Central Standard Time. You can look at that northern threat along the warm front there. And there's that cap there. I'm not really sure if this is north of that warm front. Okay. Something like this. And this kind of shape is weird, where you're pulling north of the front and taking a look south of it. It's kind of like a backwards frontal thing. Again, it's not really a warm front, but it kind of is. Differential mixing gradient. But in this very humid air, you're not going to mix as much, so you could remain capped further east. As that 500 millibar maybe jet streak feature moves in, you might be able to get some less capping further north. But the lack of large scale synoptic ascent for most of the day will be a hindrance for storm development out here. So, in terms of central Saskatchewan for tomorrow, your storm development would likely be confined to your fronts in a quite the broad region. I can even see maybe your fronts kind of extend up in here as well. You do have higher terrain out here that could get things going along the Alberta-Saskatchewan border, kind of near Cold Lake, the Meadow Lake area. But yeah, this mixing gradient, this dry punch, you can see if this is associated with stronger 700 millibar winds as they kind of come off of the mountains here. And you can see, this is actually a very nice look. I wouldn't be surprised if your soundings from here look pretty nice. Very, very long kind of photographs, not as much curvature, but definitely enough to generate supercells, and pretty fast moving supercells at that. You see east-north easterly motion at about 40 knots there, and so that's very fast, about 65, 70 kilometer an hour supercell right mover motion with your bulk shear values of 60 knots there, which is very impressive. But this warm nose at 700 millibars is definitely lingering. So from a synoptic scale, I would say your higher storm probability development would likely be further west, near that cold front and surface low. We can kind of see where that surface low is, where you have the most mass is being removed. Maybe it's another feature near the Saskatoon area. This would definitely focus things, but you kind of see maybe early convection firing out here, kind of near the Kindersley area. But yeah, I would be biased to say that your higher probabilities of seeing convection would be further north, near your cold front, near the Lloydminster area, and further east, your more volatile supercell environment. Like take a look at supercell composites. Is definitely near in the Prince Albert area. Um, very strong photographs here, but again, I don't. I'm really not sure you're gonna get storms out there until the late evening and afternoon. Um, you kind of just a flat jet streak here. Uh, might be some ascent on this right entrance region. Um, but overall, it's hard to say. Uh, so this is where probabilistic output is nice for determining thunderstorm development potential. And we'll end off the discussion with taking a look at the GEFS probabilities for all severe hazards tomorrow. But yeah, so again, not really sure if we're gonna get storms in the eastern area. You'll likely see supercell development, all the way along your cold front here, on a stronger forcing. You can even look northwest here. You have moisture pooling even north of that front as well. So, okay, your energy here. Whoa. Take a sounding. Interesting that you still have a cap out in this area here. But we can look at the HRDPS, that only really Canada's only convective allowing model for tomorrow, and you can see as a shortwave moves in, possibly early thunderstorm development in this region, and once that taps into the better moisture here, it could become surface based, and then those northeasterly winds would likely accelerate your supercells. If they're elevated, they're going to be feeling that your mean wind better, so they would accelerate off to the northeast, and as they become surface based, they'll want to turn kind of rightwards to more easterly motion. But you can see that the HRDPS is really picking up on convection, where your stronger forcing is, which makes sense. This model does show that secondary front feature, which could be interesting tomorrow. Your LCLs will probably be very high out here, but sufficient moisture pooling could definitely bring that down. I don't think the NAM or the Euro is really showing this degree of moisture pooling. 70-degree dew points. North of Highway 1, south of Leader, Saskatchewan there. Take a look at the NAM again. For moisture pooling along that front, and you can really see the difference. I believe the HRDPS is tuned better to how our terrain across the prairies reacts to heating. So this area will definitely have to be monitored tomorrow, if this actually happens. Because that is very interesting for sure. But yeah, the HRDPS definitely does struggle to get storms along that warm front. You can take a look at the other runs for this. Yeah, maybe a couple attempts along your warm front, but your storm motion vectors are going to be east northeast, so off of that front. So your warm front is as it orients itself eastward. You know, as you get this kind of triple point set up, but at that time it might be too late in the afternoon. Um, Unless you get a nocturnal low level jet that can pick up thermal advection and keep your boundary layers nice and saturated. And I would be privy to say that your highest ceiling would likely be maybe a little further north. Delete that. Your highest ceiling would likely be this area for potentially violent tornadoes, but again, uh, I would believe it would be more of a nighttime threat, if anything, if you can break that cap and if your low level jet can support that convection. Um, but yeah, I would say a nice mix in between the two setups would probably be the Alberta Saskatchewan border, where you're going to have some forcing near that cold front. Your low level pressure falls. That dry punch that kind of moves in and could get things going here earlier in the afternoon, and then of course you have your foothills set up, which I would say is almost guaranteed a storm, maybe too many storms, and could get a little messy with that bulk shear orientation. But these Alberta setups, these foothill setups with these fronts like this, usually go crazy anyways, regardless of how messy the environment looks like it will evolve. Um, we can go to, I guess we can check out Pivotal. Another field I like to check out here is your low level lapse rates. Take a look at that. It might define your mixing gradients as well. Probably won't show anything new that we haven't discussed, but it might just be nice to see it here. Here's the NAM. Go compare models loop. And you can see here, let's go 21Z. That very hot air, dry mixed air kind of moves in here. Let's take a look at what the HER is showing for your moisture pooling. I'm curious to see if it picks up. Yeah, it does a bit. Not really sure if this is convectively enhanced, or from precipitation. Let's take a look. Let's go back to this. Yeah, so in general, where your boundaries meet up here is looking like the area where your highest kind of, I think, somewhat guaranteed supercell development potential will be, with your bulk shears being southwesterly in this warm sector here. Out ahead of your cold front would near the Lloydminster area would probably be pretty favorable. We can look at the ECMWF. Let's look at the AI forecast system 0Z here. Actually, I don't believe the normal Euro is on 0Z yet. This model, I don't believe there's too much physical computation. It's purely just data-driven machine learning forecasting. But you can see here 700 millibar vorticity again. I don't think it'll show anything crazy different from the normal Euro, but maybe some energy again, some slight chunks of energy. This one is associated with your Bear Clinic zone out in Alberta here. 850. That kind of low level jet gradient here. Take taking a look here. Your low level jets in terms of vertical motion are kind of opposite to your upper level jets, where the left entrance would favor vertical motion, convergence in the ageostrophic flow in your left entrance region, and vertical motion in your right exit. Does this really happen in practice? I'm not really haven't really seen it that much, but theoretically, you should have something like that. So, could if you do get sufficient moisture pooling, like the cans are showing in this area, it could be interesting down here as well. I guess we can go to the national blend of models, kind of get an ensemble view of, will you have moisture pooling down there, or at least moisture building from precipitation out of this region. I mean, your Cypress Hills are they're down here, so, but it looks like there's a terrain feature that the moisture is building on there. I'm not really too sure what that is, but go back here, and yeah, really does tell the same story. Your regional models, the NAM, I know it wasn't showing a moisture like this out here, so yeah, if you get this scenario, you could see early storm development down here again off your higher terrain, off that very convectively mixed air mass, and that could throw a wrench into things further out here in the Saskatoon area, spit out any outflow boundaries from that. But overall, I'm personally thinking probably chasing the Alberta-Saskatchewan border tomorrow. Supercells will be moving into this kind of eastern environment that's favorable in the later afternoon anyways. So yeah, we'll likely see convective initiation near this cold front here sometime in the early to late afternoon. You can see it doesn't really progress too fast as well, which is a good thing. Yeah, we can move to GEFS probabilities as kind of a proxy forecast. Probably should have started with the Environment Canada forecast, with their hazard map. But I think this will give kind of a breakdown of what I've been talking about here. See, this is the 18Z in it here. You can see it picks up nice on the tornado probabilities along the this is quite far north, maybe near the Cold Lake area, and eastwards, moving into the evening hours, and higher thunderstorm probabilities along the border there. We go back to the GEFS and look at your flow again. That might be associated with that shortwave. Let's see here. Those probabilities really kind of spike. Let's see, 18, 21. Yeah. Could have early thunderstorm development underneath that initial shortwave. And really low odds for the east, which does make sense on a synoptic scale. Again, the eastern threat will have to be monitored in the afternoon for any cumulus fields that develop. But I have a feeling you're going to stay capped on that eastern mode. Yeah, that 500 millibar kind of feature is in between Cold Lake and southwards, so that might be an area to focus there. As you see that cirrus ripping in, watch out for any bubbling cumulus to rapidly kind of explode as the lift associated with that. Maybe some slight curvature here, which would definitely help for your thunderstorm probs. Let's take a look at the hail. To go back to actually Aguacero. Take a look at the NAM for your. Should take a look at mixed layer parcels. Take sounding across this environment here. Let's go mixed layer parcels. 1200 hail growth zone Cape. Your minus, I believe, it's defined on Aguacero here, minus 10 to minus 30 degrees Celsius. So lots of thick Cape for your mixed layer parcels. Could have drier entrainment problems looking at mixed layer entrainment Cape and mixed layer Cape. Quite the difference there. So this could boast your discrete threat in near the Alberta-Saskatchewan border and westwards along that cold front. But yeah, very unstable environment. 700, 500 millibar lapse rates, quite a bit above normal. Not the craziest you've ever seen, but you know your kind of 550 down to the surface. It's pretty steep here, and likely be seeing very tall thunderstorms out in that area. All the way up to 12 kilometers. Not sure what that is in feet, but yeah, very very explosive and strong thunderstorms would be likely out there. With more crosswise vorticity in the photograph, this would definitely be a very large hail threat. As the GEFS is picking up on out there, 30% chance for significant hail, which I believe this output defines as above at least a couple inch hail. So yeah, I wouldn't be surprised. We probably see severe analogs for hail size, the 21Z. 0Z here on the NAM. Same area. 2.75 inches. Yeah, that would definitely make sense there with that instability. So could be seeing 3-inch plus hail. To be above ping pong to. It's probably quite a bit bigger than ping pong size hail. Very large hail that you would get out there, probably 7 centimeters. You could look at the Environment Canada forecast, and they go for a slight risk. This is for today. I'm pretty tired after chasing today, and it's pretty late here, so I've been stumbling on my words. For hail, 46 centimeters there in B. I'm maybe a little surprised they didn't bite the bullet on high risk for at least this area here, because this is looking like your most favorable area for thunderstorm development, and obviously more capping out here. No thunderstorm probs out here. That will probably change if there is more agreement among the models for moisture to build down here in southwestern Saskatchewan. But overall, tomorrow has a very high ceiling in central Saskatchewan. Probably won't get too many storms out there. Your foothills will be active. Actually, I want to take take a look at the hail potential in your foothills here. Is this 23Z? Let's go earlier because your dryline circulation will probably get things going out there earlier. Nice low level, steep low level lapse rates down there. Mixed layer, yeah. Maybe not the largest environmental hail sounding in the world, but as your storms, if they become undercut by that cold front, will increase in hail potential as they normally do, and usually get your very large hail swaths on those types of evolutions of supercells. So all in all, I wonder if does the GFS pick up on tornado probabilities? Not along the foothills, but I wouldn't rule it out necessarily. Northeast of the Red Deer area, as you know that front will be acting as an area of enhanced vorticity along it. So yeah, very interesting day for tomorrow. Very high ceiling. I will probably be chasing. I guess probably would have to go north of the Lloydminster area, near the Cold Lake area. But if things eastward or even maybe near the Saskatoon area look more favorable for tomorrow, might give that a look. So all in all, looking like a very interesting day. Environment Canada will probably go for a high risk, at least on the Alberta Saskatchewan border, and if it's looking like further east, that may be extended, as you have a very nice kinematic environment for very strong supercells, especially into the late evening hours. But that will do it for this forecast. Thank you for stopping by, and let me know if you have any suggestions in the comments below. See ya.